an equation of a circle, and we know that there is a line L which is a tangent to the circle and it has a gradient of -3, and it's asking us to find the two possible equations for L. That means there are two possible lines that are tangents to the circle which have a gradient of -3. Now it does say that you must draw a sketch to help you think about this, just because drawing a sketch helps you really visualize a problem. So I'm going to write down just the key information that I have. So I've got my equation of my circle, which is this, x take 5 squared. This is obviously going to help me further down the line to work out the centre of the circle and any other information I may need. And I know that the tangent gradient is -3. Okay, I'm going to draw myself a sketch to see how there could be two possible lines, because at the moment I can't visualise why or how there may be two possible equations for L. Okay, if my the centre from this equation is going to be 5, -3. So I'm going to draw a rough sketch. 5, -3 is just around here. And I'm going to try and draw myself a circle that has a centre of 5, -3 like this. I'm going to label my centre as the coordinate. Okay, so a tangent is a line that touches a circle at one point, and it has a gradient of -3. So my straight line is not going to be have a gradient that's positive. Its gradient is negative, so it's going down in the downwards direction. Well, if it doesn't go through the circle and it only touches at one point, I can have two possible tangents. I can have one over here with a gradient of -3, and I can have the same gradient of -3 and on this side of the circle. That is why I can have two possible equations for the tangent, and the question is asking you to find both equations. So there's a lot of different elements involved to answer this question. Okay, so if the gradient of the tangent is -3, well, if I was to draw a straight line from one tangent to the other that passes through the centre, that I know is perpendicular to the two tangents, and I know the gradient of the tangent is -3. So this line that I've just drawn on myself here must have a gradient of 1/3, because the gradient's multiplied to give you -3. -3 times 1/3 is, the gradient's multiplied to give you -1 for lines that are perpendicular, and -3 times 1/3 is -1. So what I can do next is I can actually find the equation of this black line that I've drawn here. I know the gradient of it, and I know a point that it passes through. So the equation of that line, I'm just going to label it. I'm going to label it line 1. Okay, so let's try and find the equation of line 1. Now, it passes through 5, -3, and it has a gradient of 1/3. So I'm going to substitute it into my equation of a straight line. That's going to be y plus 3 equals 1/3 times x take away 5. I'm going to rearrange that. I'm going to get y plus 3, and I'm going to expand my bracket, 1/3 x minus 5/3. I'm going to continue to expand until I get it in the form y equals mx plus c. So I'm going to I'm going to subtract 3 from both sides, to give me y equals 1/3 x, subtract 14/3. That's my equation of line 1. Now remember, I want to find the equation of the two green lines. Okay, I know that to find the equation of these green lines, I need to find a point that they pass through. So I need to find the coordinate of this point and this point, because I know their gradient already. So to find the equation, I need to find the point that they cross. Now, that is a point of intersection with this line 1 that I've drawn in here. That is a point of intersection of the circle and line 1. So I can substitute this equation of that straight line into my circle wherever you see a y. So I'm going to substitute y equals a third x minus 14 over 3 into this equation of my circle. So I'm going to do that next. I'm going to do that over here. So I have x take away 5 squared plus, and instead of y, I'm going to write a third x minus 14 over 3. And I'm adding 3 to that whole thing. And I'm going to square that. That equals 10. Now it's just a case of expanding your brackets and collecting your like terms. I'm just going to scroll down. So that's going to be, I'm just going to simplify this here. X take away 5 squared plus 1/3 x minus 14 over 3 plus 3 is negative 5 over 3 squared equals 10. Expand both brackets. That's going to give me x squared minus 10x plus 25 on the left for this bracket, plus, now I'm going to expand this bracket. That's going to give me 1/9 x squared. If I simplify straight away, 10 over 9x plus 25 over 9 equals 10. Okay, so I'm going to continue to collect like terms. So if you add all your like terms together, if you add all your x squared terms, your x terms and your number terms together, you will get 10 over 9 x squared. 10 over 9 x squared. Subtract 100 over 9x plus 250 over 9 equals 10. Okay, I'm liking what I'm doing because I'm looking, my equation is looking more and more like a quadratic. Now to get this looking more like a quadratic, I'm going to multiply everything by 9 just to eliminate my denominator. So if you multiply every single term, including the 10 on the right, by 9, you would get 10x squared minus 100x plus 250 is equal to 90. Don't forget to multiply the 10 by 9 also. Simplify this, 10x squared minus 100x plus 160 is equal to 0. I'm going to simplify my quadratic by dividing every term by 10 because it's a common factor. I'm going to get x squared minus 10x plus 16 is equal to 0. Finally, I have a quadratic that I can easily factorise. Two numbers that multiply to give me positive 16, add to give me negative 10 is x minus 2, x minus 8. Solve them, you get x is equal to 2 or x is equal to 8. Okay, so I know that x equals 2 and x equals 8, they are my x coordinates for both points of intersection. So I now need to find the corresponding y coordinates. Then I can then use that to find the equation of the two green lines. So I'm going to substitute these both into this formula here, because I know that is the equation of this line. So I need to see, and that is point of intersection. So if I substitute the x coordinate, I can get the relevant y coordinate. So I'm going to substitute these both into y equals 1/3 x minus 14 over 3. Let's see what the corresponding y values are. If you substitute x equals 2 into this, get your y value, x equals 8 into this, you get a y value, and those two y values are y equals negative 2 or y equals negative 4. So the points of intersection is 8 minus 2 and 2 minus 4. 8 minus 2 and 2 minus 4. So I'm going to label those here. So that must be my 8 minus 2. And this point here is 2 negative 4. Okay, I'm very, very close to finding the equation of these two green lines. Now I have a gradient of them both, and I know the point that they each go through. So now it's just a case of writing them in the form of y equals mx plus c. So I'm now going to label this line 2, and I'm going to label this one line 3, and I need to find the equation of both line 2 and 3 to answer the question. Okay, so if I find the equation for line 1, I'm going to substitute them both into the equation of a straight line in this format, and then rearrange to find in the form y equals mx plus c. Okay, so line 1 was 2, negative 4. Okay, so line 1, I'm going to continue with line 1, so I'm going to get y. One second, sorry, line 2. So line 1 is y plus 4 equals, the gradient was negative 3, because that's been told in the question, and x, the coordinate is 2, so x take away 2. Simplify that, expand your bracket and collect your terms, you will get y is equal to negative 3x plus 2. That's the equation of line 1. Equation of line 2, y take away, no, y plus 2, sorry, because this y is negative 2 already, is equal to negative 3, that's the gradient. X take away 8, because I'm looking at this coordinate. Simplify that, expand your bracket and simplify, you will get y is equal to negative 3x plus 22. Okay, so the equation of this line I've worked out as y equals negative 3x plus 2, and the equation of this line I've just worked out is y equals negative 3x plus 22. And that is the answer to this very long question.